Hello, and welcome to this week's FSMQ video. This is part 2 of our Polynomials sub-series. In today's video, we're covering completing the square, which is the third method of solving quadratics. Let's get started. Now, for simple quadratics where a is equal to 1, for those who don't know, a is the coefficient of x squared, such as x squared plus 4x plus 8, what you have to do first is take that middle term, but disregard the x term. You want to take the 4 in this case and split it in half. So half of 4 is 2. And you're going to put that in a bracket, you're going to square that, and you're going to take away the excess. And by excess, I mean whatever that one was squared. And then you just collect the like terms, so minus 4 plus 8 is plus 4, and you get your final answer of x plus 2 squared plus 4. Now, why does this work? Well, if we consider the general case of x plus a squared, we know from our binomial expansion video that this is equal to x squared plus 2ax plus a squared. Now we want x squared plus mx plus n written as x plus a squared plus b. And to do this, we can see that m is equal to 2a in this scenario. So half of m is going to be your a term, what you're going to put in the brackets. But you still have to remove the extra a squared, because that bracket squared will create an extra number you don't want. So you subtract it back off. Now for more complex quadratics, where a is greater than 1, such as 2x squared plus 6x plus 1, you first need to take out whatever the coefficient of x squared is. So in this case, you're taking out the 2, you're factorizing out of the first 2 terms. Leave the c term. That does not need to be messed with. It'll just make it more complicated. From there, whatever's in the brackets, you just do normally. So you halve it, so 3 over 2, square it, and subtract it. What you need to remember then is to multiply that outside bracket back into your subtracted number. So we're getting minus 9 over 4 times 2 is minus 18 over 4. And then you're just collecting like terms to get 2 brackets x plus 3 over 2 squared minus 14 over 4. Now solving using completing the square is not any different from a normal algebraic equation. Here's what you may be given, but we've already solved this. It's the equation from last slide, and this is what we wrote it as. From there, you're just rearranging to get x by itself. So you're adding 14 over 4, dividing it by 2, square rooting it, make sure to consider both positive and negative versions, and then subtracting 3 over 2 to get your final 2 answers once you split it up into plus and negative. Now finally, to find the turning point using completing the square, you need to do something a little bit different. So here's the same example, here's what we worked it out as, but you will see that some parts are highlighted. The turning point is always negative a, b, and that's the x and y terms. So in this case, a is 3 over 2 and b is negative 14 over 4. And you just substitute those in to get minus 3 over 2 and minus 14 over 4. Well, this works because you want the brackets to be equal to 0 for the minimum value. So you'll do whatever cancels out the 3 over 2, which would be the negative version of it. And then your y term would be whatever's left over after that, which would be the negative 14 over 4. Alright, let's get into some practice questions. So this is our first practice question. Solve minus x squared plus 3x plus 10 equals 0 using completing the square. Give the exact values of x. Now, exact just means using the square roots. Do not decimally approximate. So let's begin. Because there's this minus here, we must first take out the technically -1 from the front. But I'm just going to write it as a minus. And then I'm going to put into square brackets x squared plus 3x plus 10, because we're leaving it outside. From here, we factorize the inside of this bracket, x plus 3 over 2 squared minus 9 over 4 plus 10 equals 0. Then we can multiply this in to get minus x plus 3 over 2 squared plus 9 over 4 plus 10 equals 0. Negative x plus 3 over 2 squared plus 49 over 4 equals 0. Now from here we just rearrange. So minus x plus 3 over 2 squared equals negative 49 over 4. Multiply it by the negative to get x plus 3 over 2 squared equals 49 over 4. Square root both sides to get x plus 3 over 2 equals plus or minus 7 over 2. And then finally subtract it all to get minus 3 over 2 plus or minus 7 over 2. Now we can combine these to get our two answers, which I'm going to write up here. In one version we have minus 3 plus 7 over 2, and in one version we have minus 3 minus 7 over 2. In this version we get 4 over 2, which is 2, and in this version we get minus 10 over 2, which is minus 5. So those are our answers. Okay, so here's our next practice question. Find the turning point of the equation minus 7x squared plus 20x minus 4. Now first, to find the turning point, we must solve the quadratic into the form of mx plus a squared plus b, otherwise known as completing the square, obviously. It's what we've been doing this entire time. But first, we have to get rid of this minus 7 in front. So this is what we do first. X squared plus, no, not plus, minus, because negative times negative is plus. 20 over 7, x minus 4. Then we do what's in the middle and factorize that. X minus 20 over 14 squared, because we divide by 2, minus 400 over 196, end of big brackets, minus 4. Now we can multiply it out. Minus 7 brackets x minus 10 over 7 squared plus 2800 over 196 minus 4. And then we can use our calculator to work out what this is. So 2800 over 196, take away 4, it's 72 over 7. So if you ever want to save time, just do a big bracket like that and do equals 72 over 7. So from this we can say the turning point is equal to minus a, b. Therefore the turning point is equal to 10 over 7, 72 over 7. And that's your answer. Welcome to the 4-mark segment of this video. In this segment, I give you 4 different questions on the different aspects of this one topic. So today's topic is going to be completing the square, obviously. We have pure, applied, proof, and riddle masks, and you can have a go at one of them, or you can have a go at all of them if you're feeling mathsy. Come back in a moment and I will give you the answers. Okay, let's get on with it then. For the pure mask, it's a pretty simple question, just like the ones we did in the practice question segment. Factorize out the 3 in the beginning, then factorize what's inside the brackets. Make sure to multiply the 3 back onto the minus 25 over 36, and then collect the like terms. From there, it's just rearranging the equation. I know I've only put x equals 5 plus or minus 7 over 6 on the PowerPoint here. However, just to be complete, the full answers would be 12 over 6 or 2, and minus 2 over 6 or minus 1/3. For the applied section, it's a very simple kind of movement calculation. It's asking you where it's at its highest. So you're just going to find the turning point of the parabola. And then once you've found the turning point, it's the x-coordinate or the time coordinate that you want to find. So that would be 2 seconds. For the proof mask, we have this kind of more generalized kind of question. All you need to do is factorize out the a, just like you would in a normal question, and then rearrange it to get your format for the turning point. Then, as I was saying earlier, because the bracket needs to be set equal to 0, you can set the equation inside and rearrange to get x equals minus b over 2a. And finally, for our riddle mask, it's not that hard of a question, honestly. It's kind of given to you. The minimum is 2, so that the final c is going to be plus 2 because everything else is disregarded in minimum calculations. And x is when x is minus 5 is when this occurs as well. So obviously it's going to be the opposite of minus 5 in the bracket, so it's going to be x plus 5 squared. So your full equation would be y equals x plus 5 squared plus 2. Thank you for making it to the end of the video. Our next video will be on the factor theorem and dividing cubic equations, and this is where the polynomial subseries gets really interesting because you're starting to do FSMQ only stuff. I have a worksheet for this lesson in the video description if you want. It also has space for doing some of the 4 mask section if you haven't done it already. Feel free to comment if you have any questions, although I only respond for the first week after posting. And if you want, you can check out our half-termly article. This half-terms was on what's the best way to teach maths and how the students respond. That will also be in the video description. Thank you so much for watching again, and goodbye.